In this video, we're going to talk about Invader bullets. And the first part is we need to have a data structure for them. I think we're going to do, we said 10 bullets, so we'll have an array of 10 bullets. And each bullet will have a texture. It'll always be the same texture. A location on the screen, which will be a rectangle. A color, I'm going to make them green. And a visible property, okay? So we need to load the texture for all bullets. We need to set the width and height. We need to load the texture for all bullets. We'll do that in the load content. We need to set the width and height of all the bullets. And we're going to set the X and Y to 0 because we're not going to draw the bullets until they're actually fired. And we will change the X and the Y values as soon as we fire it, so it doesn't matter what X and Y are at the beginning. Initially, the bullet will not be visible, and the color can be whatever we want. Okay, so let's take a look at what that code might look like. So this is what the declaration for our Invader bullets looks like. We should all have the same thing here, but let's just take a quick look at it. Each one is going to be 1% of the width of our play area, and I forgot exactly what our play area is, but let's say it's 700 pixels, and this would be 7 pixels wide. And the height is going to be 8% of the height of the play area. Let's say that's 400 pixels, and then what we would have is for 8% of 400, which would be 32 pixels. Okay, and we're going to have 10 bullets, so we're going to have an array of bullets. And so they can have more on the screen at once. And we're going to have a bullet speed, and the Invader bullet speed is going to be determined by how many seconds it takes to cross the screen. So, and that's top to bottom. So if it takes 2 seconds to go from top to bottom, and we've got 400 pixels, say, then it's going to go 200 pixels per second. And we need to divide that by 60, and so we'll get 3 1/3 pixels per tick. Okay, and then we need to compute these things using the percentage numbers up here. So if they ever change, all we have to do is change the percentages, and everything else should automatically work. Now let's flip over to our Word document and take a look at what's involved in initializing the bullets. So load the texture, set the width and height of all the bullets, and we're going to set X and Y to 0, so we just need to, they're all going to be the same size. Set visible to false and set it whatever color we want to set it to. So this is going to be pretty straightforward. So let's flip back over to our program, and we've got a little function here to initialize the Invader bullets. Well, we've got 10 of them. And did we call that Invader bullets? And for each one, we have to set a couple of things. So we are on Invader bullet, I think is the name of the array. And we're going to go to position I. And what I want to do, we'll do the easy one first. We'll set the color. Make them red. Okay. Another easy one to do here is they're always going to be false. And we need to figure out the dimensions of the bullet. We don't need to, they're all going to be the same, so we don't need to do that every time we go through the loop. We can do it once before we go in, and we should be good. So let me see, Invader bullet height equals, and this is going to be the play area rectangle dot height times Invader, we've got an Invader bullet percentage height percent, I think. Invader bullet height percent. Okay. Now this is a float. The height needs to be an integer. So we have to do a little typecasting here. So I'll make that into an int. And then we want to do Invader bullet width, and I'll remember to put the int in this time. And we got a constant for this one too. It should be invader bullet width %. Okay, so now we know how big. Well, I forgot my opening parenthesis here. So now we know how big each bullet's going to be, and now we can initialize their rectangle. So invader, come on. We're going to use 0, 0, and then we want the width, invader bullet width, invader bullet height. Now we still have to load the texture, and the other thing we should probably do as long as we're here is we should compute the speed of the bullets. So invader bullet speed is going to be, and this needs to be, let's see, it's going to be the play area height, rectangle.height, and we're figuring out the ticks, or the pixels per tick. So I want to divide that by invader, and I want the time to cross the screen for seconds to cross screen. So if it's 2 seconds, you know, and it's 400 pixels, then we'll be doing 200 pixels per second. But I have to divide that by ticks per second. I made that a constant too. It will normally be 60, but you can't change it. So now we get everything calculated except for actually loading in the content for the bullets. So we'll go down to load content and we'll do that, although I'm not sure that you actually have to put everything, all of your content loading there, but we've always done it that way. So we'll move down there. So now we're in load content, and we just need to write a for loop to load the invader bullet, which I called invader missile in the content. So I is less than invader bullets, and we want to just load the texture. So invader bullet sub I dot texture equals content dot load, and it's going to be texture 2D, and then let's get the name of the item here. It's invader missile. Okay, so we got the bullets initialized, and then what we have to do is we have to figure out, on a given tick of the clock, do we need to fire a bullet or not? Okay, so let's flip back over to our Word document. And we have updating bullets. So to see if we're going to update a bullet, we're going to fire one. So 30 goes into 1,000, you know, about 33 times. And so we're saying that there's about 1 chance in 33 that a bullet will be fired. And since we're doing 60 ticks per second, that means we should get, on average, about 2 bullets on every tick. Okay, so to see if it's time to fire a new bullet, all we have to do is generate a random number, and if it's less than 30, then we're going to fire a bullet, and if it's not, we're not going to do anything. So let's flip over to our code window. And we're going to write a new function, void initialize. Not initialize, we just did initialize. Update. So we're going to see if it's time to do a new bullet. So we need a random number generator, and I don't think I have one declared. Let me see. If I do not have one declared, so I'm going to jump to the top of my document here, and I am going to go to the bottom of my declarations, and at the bottom of my declarations I'm going to, that's probably not the bottom, I think I put a gap in there, so we were isolating some of that code. So we're going to have a random number generator, whoops, parentheses, okay? And then we'll scroll back to where we were updating the bullets. So here we are updating the bullets, and what we want to do is if ran.next, and we'll put 1,000 in there, is I'll give us a random number from 0 to 999. If that is less than 30, then we put the code here for a new bullet. Okay. If it is not less than 30, we just don't do anything. We continue on with updating each Invader bullet. Okay. So what do we have to do to update each Invader bullet? Well, for we got to look at every one. And what do we want to do? We want to see if it's visible. If it's visible, we're going to move it. If it's not visible, it's not in use. So if Invader bullet is visible, then we're going to move it. So so if the Invader bullet is visible, then we need to move it in the Y direction. So we need to change its Y value. So Invader bullet sub I dot rectangle dot Y plus equals Invader bullet speed. Okay. Now we're going to get an error there because this is a float and the rectangle Y coordinate is an int. So I need to convert this to an int. I think that'll get rid of my red wavy lines for me. Now, this is going to have a fraction on it, and when we're moving the invaders, because they move so slowly, we actually need to keep track of the fractional part. Here, it's not really going to make a whole lot of difference, although we could. If we did that, we would have wanted to declare an extra Y variable as part of our sprite struct, and we didn't do that. So this will move the bullet if it's visible. Okay, and if it's not visible, we don't want to move it at all. So this will update all of them, and after that happens, we want to check to see if there were any collisions. And we can probably do that in here because we're only colliding with visible bullets. So let's check to see if Invader bullet, if its rectangle intersects player dot rectangle, then player has just lost one of his lives. Okay, so we have one called lives left, player lives left, minus minus. If player lives left is equal to 0, then the game is over. So we want game. Come on. Game state equals game over. Okay. And otherwise, our game state will just be paused. Okay. And we'll wait for the player to push the start button to start firing things again. Okay. If the game state goes to paused here, it seems like the fair thing to do would be to hide all of the bullets. So if there's another bullet that's just a fraction of an inch away from the player, he doesn't get killed again when it starts up. So if there's a collision, then what we want to do is take each player invader bullet and set its visible property equal to false. Okay. So this takes care of killing the player. And for int I, I'm in a loop that has I already, so we got to do J here, and we got to do J here, and we got to do J here. I'm so used to always using I for my index variable that sometimes I forget that I'm inside of another one and I have to change it. So, so that's what we'll do, and I think that takes care of that. So we're moving each one. If it's visible, we're moving it. If there's a collision, we knock off a life, we pause, we basically start over with the invader bullets, and if the lives is 0, we go to the game over state, and I don't think we need anything else here, so I'm just going to get rid of these brackets here just to clean it up a little bit. Okay. Now what's remaining is finding when it's time to fire a new bullet. Okay. So what we have to do here, if we're going to fire a bullet, we need to find a row and a column where it's going to go. I'm sorry, just a column where it's going to go. And so let's put some comments here. Our column is going to be equal to a random number so that'll give us a number from 0 to 9. And that'll tell us what column it's going to be in. Okay. So if I'm in column 0, I can use the x coordinate of invader 0. Now that'll be on the left side of the invader, but we're not going to get too picky about that. If it's 1, then we want to be firing it from the column where invader 1 is, and if it's a 2, where invader 2 is, all the way up to invader 9. So get a number from 0 to 9, and that'll give us our column number, and we can use that as an index into our invaders to figure out what their x coordinate is. We're also going to figure out a y coordinate for the bullet, and okay, so use column to find the y coordinate for the bullet. It'll be the same as the invader coordinate that's in that column. Okay. So now we got the y coordinate. We already have the width and the height. We need to make the bullet visible. But first we have to find a new bullet. Okay, let's talk about this algorithm right here. So how do you find a new bullet? Well, you just go through the list of bullets, through all 10 of them, until you find one that is not visible. So let's do for and as soon as we find one that's not being used, its visible property will be false. Then what we want to do is we want to save the bullet index. So I'm going to declare a variable here for the bullet index. So this is the one that we want to make visible now. So that's going to be position I. And then we need to quit. We need to jump out of the loop, so just do a break instruction and we will jump out of this loop, and then we'll go down here. So we know our bullet index is going to tell us which bullet we're going to use. We're going to find that bullet at that position. We're going to find its rectangle and set its column equal to a random number. Then we're going to use this to go look at the invader's rectangle coordinates and set that should say x. Find the x coordinate of the bullet. We're going to set it equal to visible, And then we need to figure out where we're going to fire it from, what the y coordinate is going to be. And we can just take the y coordinate of something in the bottom row. Now, if the bottom row is all wiped out, I don't care. We're trying to keep it relatively simple. So all the bullets will come from the bottom row, even if there aren't any invaders left in the bottom row. Okay? And even if there are no invaders left in a column, we will still, once we get this random number for a column, that's where we'll fire from. Okay? You can go back and clean this up some other time if you want to, but for right now, this is good enough. So now what we want to do is we want to make the bullet, want to find its y coordinate, and it's going to be the y coordinate of anything that's in the bottom row. And I know that the last item is always going to be in the bottom row. So the bullet y coordinate is going to be equal to the invader except it's not going to be I. It's going to be invaders. That's number 50 minus 1 will give me the 49th item, which is the last one. Okay. So this code shouldn't be too hard to fill in, and that should be what we need. I'm going to flip back over to my Word document here for a second and just see if I forgot anything. So creating a new bullet, step through the array and find one that's not currently being displayed. We've done that. Determine a column, a random number from 0 through 9. Determine a row for it to appear in, and we're always going to fire from the bottom row. And exit the loop so you don't have the invaders shooting more than one bullet at a time. Okay. Actually, we did that up here, and then when we fell out, we did this stuff. So you could have written the code a little bit differently, but it all comes out the same in the end. So if you are not creating a new bullet, you still have to update all the visible bullets. So that's the code that I actually wrote. And we need to step through the array of bullets looking for bullets that are visible. For each visible bullet, move it by updating its y coordinate. The x coordinate never changes for a bullet. If after moving it is collided with a player, update lives left, make the bullet invisible, and move to the pause state. We did all that. If after moving it, it is not collided with the player, see if it's touched the bottom of the screen. I forgot that. Okay, so let's go back over here. And if it is visible, we move it, and if it intersects, we do that. Else, if it doesn't intersect, we're going to check to see if the invader rectangle, okay, I forgot the T. If invader bullet dot rectangle dot bottom is greater than or equal to my play area bottom, then it's no longer visible. So we just said it's visible property, so it's going to be invader bullet. Okay. And that should take care of it. So you have to write a little bit of code up here to generate the new bullet, but we've got most of our code written for figuring out if we're going to have a new bullet or not. So that takes care of that.